Let's start our notes for section 4.2b, which is about exponential and logarithmic equations. In this video, we're going to talk about just one type of exponential equation, and then we'll pick up with more later. You can see here we have kind of three basic instructions for solving an exponential equation, which is any equation, so there's an equal sign, that has exponential stuff in it. So you can see something like this first example we're going to do counts as an exponential equation. All right, so we want to isolate the exponential, so get whatever the exponential thing is alone, write it as a logarithm instead, and then continue solving for x. And I want to talk about this middle cue before we actually do it in an example. So if we have log base b of x equals y, this is saying that y is the exponent b needs to get to x, right? So we're going to use that language to backtrack to its corresponding exponential. So y is the exponent that b needs to get to x. So in these examples, whenever we have an exponential situation, we're going to rearrange it so that the exponential base is the log base. What was the little exponent up in the air is now the right-hand side. And then what was on the right-hand side is now in the logarithm. Okay, so in this first example, the first step is already done. When we say isolate the exponential, we mean get it alone. This 3 to some stuff is already alone. And of course, our task here is to solve for x. So we're going to go straight to the second part of the instructions here, write it as the logarithm instead. Okay, so here we go. So 3 is the base of the exponential. So now it's going to be the base of the logarithm. What was up in the air as the exponent is now the right-hand side. And then what was alone over here is now in the logarithm. So that's the thing. So log base 3 of 5 equals 2x minus 4. And now we can solve for x kind of in a more normal way with algebra. So I can add this 4 to the left-hand side and then divide by 2. And my answer is log base 3 of 5 plus 4, all divided by 2 equals x. So typically that step, when we turn the exponential into a logarithm, that's the trickiest step of the whole thing. There is another way to see this work that kind of gets you to this place in a different way, just because it's so tricky on the mind to get things in the right spot. So I just want to show you what that other way would be. And then from now on, you can kind of choose which one seems better to you. So I'm going to switch colors here and just say, or when we have 3 to the whatever equals 5, because 3 is the base of this this exponential, I'm going to log base 3 both sides, right? As long as I do the same thing to both sides, it's allowed. So I'm going to do log base 3 of the left equals log base 3 of the right. On the right side, log base 3 of 5 is just kind of stuck where it is. Nothing special happens there. But on the left, the 2x minus 4 comes down. And log base 3 of 3 is 1, right? That's the exponent 3 needs to get to 3. So we end up with 2x minus 4 on the left equals log base 3 of 5 on the right. And that's exactly what this step was right here. The left and right sides have switched, but we have 2x minus 4 on one side, log base 3 of 5 on the other. So you can always choose to do it this way if that rearrangement step doesn't really work smoothly for you in a consistent way. All right, let's try another one. I have 3 examples total in this video. This is the first one where we do have to do the first step here, isolate the exponential. So we're still solving for x, just like the first example, but the e to the stuff is not alone in this equation. It has this plus 2. So I'm going to start by subtracting the 2 over to the right-hand side. And I get e to the x minus 3 equals 5. Now the exponential is alone, and I can choose to either rewrite it as its equivalent logarithmic statement, or I can do it this way here. For this one, I'm going to structure it this way just so we can see it in action from the beginning. All right, so since e is the base of the exponential, I'm going to log base e both sides, meaning ln both sides. On the left-hand side, x minus 3 comes down, and I have ln of e left over, which is 1, just like we had over here. Or you could see this as the composition of inverses and just cancel these, so the x minus 3 is alone. But either way, we end up with x minus 3 on the left equals ln of 5. Now it's only one more step to solve for x. I'll just add the 3 over, and I get the ln of 5 plus 3 as my answer. Let's do one more example. Right. So again, we're solving for x. We have an equal sign. We have an exponential thing. So we're going to follow the prescribed steps. First, I need to get the exponential part alone, this 5 to the stuff. So I'm going to get the 1 added to the right-hand side, and I have to divide the 3 away so that just this part is alone, and then I can do one of these two methods to get the logarithm. So if I add 1 to both sides, I get a 12 on the right, and I'll divide both sides by 3. So it cancels on the left, and I have 4 on the right. And now I have my choice. I can rewrite this as an equivalent logarithm statement, or I can get to the same place by log base 5ing both sides. Log base 5 of the left equals log base 5 of the right. 2x minus 9 comes down. Log base 5 of 5 is 1. Log base 5 of 4. If this were a nice number that I could actually compute by hand, I would do that. Since log base 5 of 4 is not something I can do anything with without a calculator, I'm just going to leave it in that form. So I have 2x minus 9 equals log base 5 of 4. Add the 9, divide the 2, and we're done. Adding the 9, and then we'll divide the 2. So we get log base 5 of 4 plus 9 divided by 2, and that's my answer.